Welcome to this webinar on understanding the shift deform and reference node functionality in D3PLOT. My name is Katie. I'm an engineer at Arup with some experience using LS-DYNA and the Oasys software suite on automotive projects, as well as for structural and seismic applications. Firstly, some housekeeping relating to the webinar. All the webinars are recorded and available to watch on our website. If you're joining live, please keep yourself muted during the webinar. If you have a question, you can type it in the chat and I will try to answer them at the end. And finally, the webinar will last around 10 to 15 minutes. So the focus of this webinar is to better understand some of the options under the deform button in D3PLOT, of which there are several. And this is where the deform button is located in the software. The first of these options is explode parts. Which artificially separates parts by applying explosion vectors to them. That's what we can see in these two images here. The next one is magnify, which allows you to put a scale factor on graphical displacements to make them appear bigger or smaller. So I've magnified the deformation from the first image to the second image. The next one is reference state, which allows you to contour results relative to another state in time or even another model. The next one is transform, which allows you to translate, rotate, reflect, or scale a model. And the final one, which I'll just touch on briefly, is status, which simply shows you which of these options you have on or off at any given time when you're working with a model. The next three options, which are in this red box, fixed node, shift deformed, and reference nodes, are the main focus of the webinar, so I'll go into those ones in a lot more detail. So the first tool we'll look at is fixed node. This tool allows you to specify a node which remains fixed at its undeformed position, regardless of any displacements which occur during the analysis. And to illustrate how these tool works, I'm going to use this simple example model, which is a tube being crushed. If I just slow that down a bit, go back to the beginning. So tube being crushed by two plates at either end, which are free to rotate. So to fix a node, I go to the deform menu, fix node, and then I can choose a node by picking it on the screen. I can also type in the node ID into this box here. If I play the animation again, I'll go back to the beginning, and I show which node I fix by toggling this option on or off. With this button here, which is actually a new feature of D3PLOT 19, I can see that my chosen node is now fixed in space. And what is actually happening is that D3PLOT is finding the displacement vector of the fixed node at each state and then subtracting that vector from the coordinates of every other node in the model. So we're seeing the motion relative to the motion of our fixed node. And so this tool might be useful if I wanted to focus on the behavior in one part of the model and not have it moving around on the screen. So if I turn this fixed node option off now, you can see I go back to what I was looking at before, where that node is clearly moving across the screen. So I'll switch off this option again, and we'll take a look at the next tool, which is shift deformed. Shift deform is actually quite similar to fixed node, but whereas fixed node only adjusts the way we were viewing the translations, shift deform will adjust for rotation as well. So in this crush example here, if I wanted to measure like the maximum end-to-end deformation between these two plates, it would be quite difficult to do because they're both rotating. And an automotive application of this would be measuring crush, where the vehicle will have likely undergone both translation and rotation. So to turn on the shift deformed option, I'm in this menu here, deform, shift, def, and then I have to choose three nodes which define a coordinate system. And I can pick those from the screen, 1, 2, and 3. Alternatively, I could use the save and retrieve option to choose a coordinate system for my ZTF file, or one which I stored earlier in the session. So I've chosen three nodes on the blue plate, which you can see sketched here. Again, you can toggle on and off the sketching of the nodes with this show nodes feature. And the order I chose these nodes in is actually quite important. The node I chose as node 1 will behave like a fixed node from the previous tool we just looked at, and the 3 nodes then form a right-handed coordinate system where the vector from node 1 to node 2 is its local x-axis, and you can see that coordinate system sketched here as well. And so when you're choosing those 3 nodes, it's best to pick 3 nodes which are representative of rigid body motion so that their relative displacement does not change too much as the model deforms. So if I now animate my model again with the shift or form options switched on, you can see that the model has been rotated with respect to this coordinate system defined by node 1, node 2, node 3, and translated back to the undeformed position of node 1. So node 1 is fixed in space. So it's as though the translation and rotation of the rigid body formed by this coordinate system is fixed in space, which is a bit different when I just had the node fixed in space. We could see that this plate was still rotating. A final note on this tool is that fixed node and shift to form, as they both translate the model relative to the motion of a specific node, they can't be used at the same time, as these translations would conflict, and D3PLOT will actually warn you of this. So if I now try to go to the fixed node menu, it's letting me know that they can't be used at the same time, and if I press OK, it will switch the shift to form option off. So far we've looked at fixed node and shift to form, and both of these tools only changed the way the model displacements were being displayed, but they will not have changed any contoured values. So leading on from that, then the next tool we'll look at is reference nodes. And unlike fixed node and shift to form, it doesn't affect the way the model displacements are displayed, but it does, however, change the contoured values. So if I go to then deform ref node, you'll see that I've now got the option to choose a single node or to choose 3 nodes. If I choose 1 node, I can plot displacements, velocities, or accelerations relative to the chosen node. So if I go to a point in time and plot the x displacement, at the moment I've got no deform options on. And say I was trying to estimate the distance between these 2 plates to measure the crush of this tube, for example, I might be able to estimate it by summing the 18 and the 97 on my contour bars, but it would only be an approximation. It's a bit difficult to determine. So now if I go to deform ref node and pick a single node, so maybe I choose this node here. Now I'm viewing the displacement contours relative to the displacement of that node. So you see that the node that I've chosen is now showing as having a displacement of 0, and the node on the other side 115. If I turn this off again and sum the 18 and the 97, I would then get to the 115, but this is a much easier way to view that sort of result. So I can see the x displacement of the node that I've chosen has been subtracted from all the other values. So right now I'm just looking at the contours relative to the displacement of my chosen node, but I can use this button here to toggle on the fixed node option, which was the very first tool we looked at, to also view the displacements graphically relative to that node, which then makes it a bit easier to understand because then the graphics and the contours are matching up. So I'll turn both these off and then we'll have a look at the 3 node option. So it's much like shift deformed in that the 3 nodes I choose will form a coordinate system and the displacements will be plotted relative to node 1, like in the single node option, but the contoured displacements will also be corrected for rotations of the coordinate system formed by the 3 nodes that I choose. So I'll choose 3 nodes again. Now I can see that the displacement of this whole plate is at 0. And so the contours are now adjusting for rotation as well, because I've chosen use the 3 nodes option. And at the moment, I'm plotting the displacements in the global coordinate system, and I'm looking at the x displacement. I could also choose to plot the displacement in the local coordinate system formed by the 3 nodes I picked by choosing this option here. So if I change to that, I'm still now plotting the x displacement, but the x displacement is now in this direction, which is more like my global z displacement. And that could be useful because then I could plot the local z displacement, which I know would be the displacement normal to this plate. And again, like before, I can use this button to toggle on Shift Deformed, the second tool we looked at, again, so that I'm viewing the graphics. What I'm viewing in the graphics is the same as what I'm viewing on the contours. And like before, I can't have the single node option and the 3 node option at the same time because they're conflicting. So if I play this animation, because I've got this option toggled on, the contours that I'm looking at and the graphical display that I'm viewing match up, and I can see that I've fixed the rotation of this plate, and this would make it much easier for me to measure the crush of this tube. So finally, a summary of what the webinar has covered today. Fixed node and shift deform, they both change the way the model displacements are displayed, whereas reference nodes, the 2 reference node options change the contoured values. The ones in the sort of top row of this table are similar to each other in that they're fixing the deformation of just 1 node, whereas shift deformed and reference node, these 2 are changing the deformation relative to a coordinate system which is defined by 3 nodes. And I can't have fixed node and shift deformed on at the same time. Likewise, I can't have reference node 1 node and reference node 3 node options on at the same time. So thank you for listening. Hopefully that's given you more of a feel of how to use those tools which come under the deform menu in D3PLOT. I'm happy to take any questions now live. I'll check the questions chat. But if you're watching on YouTube and you have a question, or you have a question later on after this webinar, please feel free to leave a comment on YouTube or to get in touch with your local sport team, the contact details which are here.